Now we're going to look at the second problem. It is to use the L'Hopital's rule to find the following limit. That is, when x goes to infinity, we wish to find the limit of 1 plus a over x to the power of x. Okay, so we're going to look at this function carefully. We can see that when x goes to infinity, 1 plus a over x goes to 1. Okay? That is when x goes to infinity. And the power is just x, so x just goes to infinity. So we're in the situation of 1 to the power of infinity form. Okay? And then we're going to use L'Hopital's rule to find this limit. Alright, that is limit of x goes to infinity of 1 plus a over x to the power of x equal to, because we have x in the power, it is always a good trick to use the relation between exponential function and the log function. That is, we firstly take the exponential and then take the log inside of the original function, and then nothing actually change. Okay? And then we can use the property of the log function and bring the power x in front of the log function. So that is x times natural log of 1 plus a over x. Alright. And then, because exponential function is a continuous function, we can switch the limit and the inner argument. And then we will have this equal to exponential of limit of x goes to infinity of x times natural log of 1 plus a over x. Alright, now we're going to consider about this inner part. Okay, when x goes to infinity, this first factor x just goes to infinity, but for the second part, it is natural log of 1 plus a over x that goes to 0. So we're in the situation where infinity times 0. So we can use the property of the algebra and rewrite this as the limit of x goes to infinity of natural log 1 plus a over x divided by 1 over x. Now we can see that for the numerator, when x goes to infinity, the numerator goes to 0. And when x goes to infinity, the denominator, which is 1 over x, also goes to 0. Now we're in the situation of 0 over 0. And then we can apply the L'Hopital's rule. And apply the L'Hopital's rule, we will have exponential of limit x goes to infinity of 1 plus a over x inverse times the derivative of a over x. So if we find the derivative of a over x, it is actually equal to negative a over x squared. So I'm going to replace this part by negative a over x squared. Okay? And then for the denominator, if we take the derivative of 1 over x, and we will have negative 1 over x squared. And if we simplify this expression, and we will have the exponential of limit of x goes to infinity of a over 1 plus a over x. And then at this time we can just bring the limit into the denominator, and we will have exponential of a over limit of x goes to infinity of 1 plus a over x. And this limit in the denominator is actually just 1. So we will have the exponential of a over 1, which is just a. And this will be our final answer, which is e to the power of a. Or in some other form, e a. Okay? This is the end of this problem.